So, it seems that we are live, and today I will be doing day 2 and possibly day 3 of Advent of Code. We will start with day 2 in Julia, and we will be using Julia's amazing REPL to guide us through. And as usual, I haven't seen the task yet, so I'm quite excited. I guess let's get started. Rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose stand gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Blah, blah, blah. So it explains rock, paper, and scissors. Rock defeats scissors, scissors defeat paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide that they say will be sure to help you win. The first column is what your opponent is going to play, A for rock, B for paper, C for scissors. The second column, certainly the elf is called away to help you with someone's stand. The second column, new reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is a score for the shape you selected. 1 for rock, 2 for paper, and 3 for scissors. Is it the same order? Yes, exactly. Plus the score for the outcome of the round. 0 if you lost, 3 if the round was draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide. A, C, Z. In the first round, your opponent will choose rock, and you should choose paper. This ends in a win for you with a score of 8. In the second round, your opponent will choose paper, and you should choose rock. This ends in a loss for you with a score of 1. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. So now if you sum all of that, it will be 15. What would your total score be if everything goes exactly according to your strategy guide? Alrighty. So this is our input. Let's copy it as usual. So our last thing is BZ, and our first thing is AY. Let's double check. AY and B that, exactly. And now we need to encode it, so let's roll. This is the one input. Let's create a file here. And let's enter the Julia interpreter. Right, see. I just updated Julia, and I might have made my life a bit more complex because it seems that Visual Studio Code doesn't yet know what to do with this version of Julia. Maybe we can quickly reload. Okay, I guess we will just rely on the REPL. I guess let's start with reading our magic file. So to get the input, oh man, this is very confusing. Let's start right here, I guess, input. Oh, and I think my font setting, yeah, that looks better. No such file or directory. Inputs, 0. Okay, we got a vector. I think Yes, that's how you do it. So parse input. We start with that, then we do, let's do chomp. That removes the last n thingy. And then let's do split. I wonder if it will split. Okay, we will need to do that without carrying, it seems. So let's do it like that then. This will be our input. Then we take this input and we do a split. And yeah, I don't have anything here. So let's quickly look up what was the order. Okay, second is the character. So split in the, I think we can use string, doesn't really matter. Exactly. Now let's quickly copy this. So this is first condition we have. And then we have X for those. And then, so those are points. And what was else here? For scissors, oh yeah, outcome of the round. Majestic. Okay, those are the conditions we have. Now, we split it, and we now need to iterate through this. Let's continue with this thing. So, which means we can do it with map. So we can take this, and for each of those, we can run split. And I think that was the order. Let's first execute this. Exactly, looks correct. Yep, it does. So now we essentially can just return this. Got our parse input function. What do we do next? We need to go through this thing. So let's do part one in, and then we say end. We go through each of those and we check who wins, and then we assign points, right? So we will need point, and this accepts round. Round is just an array, so, or like play, I guess. A for rock, B for paper, C for scissors, or X, Y, Z. One for rock, blah, 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 and then outcome. And of course, just in case that I will mess it up, let's copy this as well. So, not that I forgot the rules, but it's easy if you have text and you can just cross-reference it. So, essentially, I never thought if there is some kind of a sequence in here, like if we can use comparison or something like that for that. So rocks defeat scissors, scissors defeats paper, and paper defeats rock. So it means, let me check it. Rock is larger than scissors. Scissors are larger than paper, and paper is larger than rock. So scissors, rock. Okay, no, it doesn't follow transitivity, so you cannot do this. Okay. Alrighty, then we just do dictionary, right? We don't need to overcomplicate it. It's not a good idea usually in Julia to define a global variable, but in this case we can kind of do it because we don't care. It's a very small task. So maybe we can then don't even need a function here. It can be just a dict, because ultimately we only have those possible variations, right? So we only have essentially it feels very weird to do it, but why not? Yeah, actually, B is for paper, Y is for paper, so that we don't need. And that. And A is for rock and X is for rock, so that we don't need. A is for rock, Y is for paper. Paper defeats rock, so when paper defeats rock, which means we don't get a point, right? Because, yeah, rock, paper. No. We do get a point. Y for paper. Paper defeats rock. Okay, no, this will be super confusing. So better, let's decipher this thing. A will be rock. B will be paper. C will be scissors. X will be rock. Y will be paper. And that will be scissors. That's it. Decipher. I don't know yet if there will be some trick in the second part where they say, okay, now it's in reverse and you need to do everything differently. Like maybe it's not correct explanation of those three. But for now, let's just do this. Y for paper and Z for scissors. And then we can also say points, and that will be sign points maybe. So rock is 1, paper is 2, and scissors is 3. Magic. And you can use symbols and stuff here, but I wouldn't bother. Yes, that is encoded. And then let's say outcome, maybe. Outcomes. And we only need to calculate our own thing, right? We don't... Your total score. You should choose paper. That ends with you. Okay. So let's also copy this example so we can quickly run it and test that we didn't encode something. Dump. So, anyways. Let's do all scissors, rock. This will be 3, paper, 3, rock, scissors, 3, paper, scissors, rock, scissors. It's not complete, the rules, right? Rock defeats scissors, scissors defeats paper, and paper defeats rock. Oh, rock, paper, of course. So those are 3, and then those are only win outcomes, right? Okay. So now we have 3 magical dictionaries. What we can do is just create total score, and then no, let's still do the function because that will be easy. Function score move, and here we can move will be array, right? So input is vector of vectors. Okay, so it will be a vector. We map this move. Let's create a variable for now. So let's say move will be something like that. Oh yeah, Julia is 1 indexed, of course. So let's do it like that. Can we apply? Okay, I'm not sure if this will work, but I can try and see. Okay, doesn't work. That was worth a try. Please say that this will work. Exactly. Rock and paper. Is it? Rock and you choose paper. The answer in the win for you. So deciphered move. Then 8. Okay. Win outcomes. Was it has key? Exactly. Yeah. Deciphered move. True. I think even before that we can say if deciphered move 1 is equal to deciphered move 2, was it? Yeah, it's else if here. Else if or else. And okay. So if they are equal, it means that it's a draw. 3 if the round was a draw. So that's a draw. If you won, it means you get 6. Win, and otherwise you get no. Loss. And you always add to that your move. So it will be 3 plus sign points. SP, let's call it like that. So it will be sign points for deciphered move 2, like that. Round outcome. Actually, we don't need a variable here, so you can say like that. Sign points, round outcome. Let's see, can we do this? Score move, and we just take A, Y, 8. Perfect. BX. Let's try them all quickly. One. CZ. 6. Perfect. Which means now we can just go through our input. So total score 0 for X in. Was it? Man, I forgot syntax for that. This is pretty amusing. Oh, I probably should not have called it in. Because I do think it's in. But it so far didn't fail. Okay, sorry, I need to check. Something like that. Can I do it? No, maybe. Is it really in? Okay, it's really in. So that was really bad. See, that's what happens when you work with too many different languages sometimes. Magic. Now we just do this. Score move. Actually, what am I doing? I can just write. Yes, that should be. And then I can just do some. Right? Well, it's still coding here. Let's see if that worked. Ta-da! Continue to part 2. Alrighty, the elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. Both now goes like this. In the first round, your opponent will choose rock, and you need the round to end in a draw, so you also choose rock. This gives you a score of that. In the second round, your opponent will choose paper, and you choose rock, so you'll add with a score. In the third round, defeat your opponent's scissors. Well, this is very simple. We just look at this x, y, that, and add those points. We don't need to calculate them anymore, right? We don't need to select the function. We don't need to select the shape, right? You would imagine that you maybe need to do it, but actually we can just look at this and get the second, the round outcome value directly from the second element in the input vector. So that should be that. Let's just say P2 round points. That will be another dictionary. Which will be just that. But X means you need to lose, which means 0. We needs to end. Y means 3. And Z means 6. Exactly. So let's define this. And now we can say, oh, well, it makes it even easier. We just take 2 round points, move. We look at our move. plus V and sign points for that. Is that? Seems so. So part 2 then will be, guess what? Oh yeah. Oh, is not callable. Did I? Oh yeah, of course. I think you need to redefine it. So let's see. Whoa! If you're stuck, you make sure you use the full input data. Man. Okay, was too fast. I mean, idiot. Of course. I do need to still select this, right? Alrighty. That was a bummer. We need to still do it, it means. So how do we do it? If we got 2 round points, outcome, if outcome is a draw, so if outcome is a draw, it means we just copy what the opponent has, right? So we can look at this and we just, yeah, that's what we return. If outcome is a win, it means, so scissor beats rock. Rock beats scissors. So this should be second one, right? We need to decipher opponent sign. Take this, we decipher it. So, and then sign. Do we try to do anything smart here, or do we just ignore it? Because maybe we can create win outcomes, 2 new dictionaries from that. So if we, second element here is always the winning element, which means paper, scissors. Yeah. Why did I even do it into a dictionary? That's a bit weird. Win outcomes. Strange. Anyways, no, let me quickly check it and see. Score move. Has key. I only look at this. So this is just like, we can reformat this in. So this is like winning response. Hold on. Paper, scissors. Exactly. Win sign. which means this becomes in science this, right? Let's quickly check it to see that we still do correct thing here. I think it is the correct answer, 10,595, right? Exactly. Okay, good. Which means here then it will be just in science opponent sign. Exactly. And otherwise, if you need to lose, you need to essentially, if it's paper, you need to invert the dictionary, right? So this will be lose signs. And that will be interesting. So I wonder, can I even do that? I think so. Let's try. Will it work? No. How do you go through keys? Let me quickly check it, because I think Julia, there was some magical method for that. So dictionaries, key, collect keys, copy keys, values. How do you Julia iterate through key values? It was something like item. I guess I can just collect it, right? I probably can just win signs. What I do if I do collect on it? 3-element vector, exactly. So I can do this, and then I should be able to do something like that. So does it want me to select it, like key value, and then you do like key value 2, key value 1? That doesn't look very pretty, but that works. So paper, rock, exactly. So those are like losing outcomes, and then of course you can pipe it into a dictionary. Yay. Probably would have been faster to just write it down by hand, but that's not fun, right? So this is fun, yeah? Which means opponent sign, decipher, move on. We will refactor it, of course. Now, I'm a bit less certain about my ability to score it immediately, so let's do a test. What was there? So that was, okay, let's make it into an input. Naturally. Right? So test input looks very ugly. Okay, that will break, but doesn't matter. Oh man, yeah, it will be. I guess I need to do those. Let's just make it into one line. Just add this and this. Oh, Okay, that will be annoying. Okay, score move 2 will be test input. KPX is not found. Get index. Oh yeah, of course. Test input 0. Test input 1, too much Python. Key A is not found. So test input 1 is this, AY. This is our move. Outcome then is this. Okay, and then A. Oh yeah, sign point is we need to pass it through decipher, right? 4. Is it correct? 4. All right, see, and it should now be 12, I think. So we redefine this and we redefine that. And now let's see, test input. What don't you like? Key rock not found. Decipher, loose sign, opponent sign. So score move 2 is used here. Test input 1 works. Test input 2 doesn't work, and test input 3 doesn't work. Key error is not found. B surface to paper. X is, in this case, X means what does it mean? Outcome P2 round points. So let's look at it. V and X. It should be, you should lose. So outcome is 0, which means paper. And then we need to find a loose sign for paper. Paper is rock. Oh, and we need to decipher it back. Oh man, this is annoying. Stop. But that means that we just need to put decipher here, right? Exactly. So let's see. Score move 2. Move 1. Was it correct? 1. Correct. Okay, good. Which means part 2. Okay, that may be our answer. Sorry. I wanted to try it on test input. 12. Okay, that's correct. So now we can try it on our normal input. It's 9541. I hope it was not the... Ta-da! Done it. Alrighty, we had 40 minutes. So, okay. First time writing Julia in like 3 months. So it was a bit slow, but we solved it. I guess I will do a bit of refactoring on it after the stream and then also push it to the repo so you can see there. I must admit, working with REPL feels way better than it felt yesterday to work with Livebook. Oh, not yesterday, on Thursday, whatever. Because it is a workflow I'm way more used to, and for this kind of tasks at least, even though I was doing a lot of weird switches and was very indecisive in the beginning. But well, we will become better the more we go through this. I will do a little break and we'll start another stream where we will continue with the day 3. See you in a bit.